hear me? Perfect. So thanks a lot for attending this presentation, and of course for the invitation to provide, let's say, my perspective on the developing hydrogen market and the future of that market in the next decade or so. So my name is Oscar Kraan. I'm an energy strategy manager within Monitor Deloitte, which is a strategy practice of Deloitte Consulting in Amsterdam in the Netherlands. Been involved in the energy industry already for more than 10 years. Did my PhD on energy transition scenarios, and well, over the last couple of years, supported the industry on a couple of interesting projects, I would say. So the last year and a half, I've been working on the feasibility study for NordH2, which is the largest green hydrogen project in Europe. So it's 4 gigawatts of offshore wind plus electrolysis in the north of the Netherlands. And we're working with a consortium of Shell, Equinor, RWE, Gasunie and Eneco on developing that project. We've also been working with Shell on the decarbonization of the hard-to-abate sectors, so road freight, shipping and aviation. We've published public reports on that, so I think that gives you a very nice overview of, let's say, the industry's view on the decarbonization, the challenges and its opportunities. Relevant for this audience is, of course, also that we worked with Gasunie on the hydrogen strategy for, let's say, repurposing their gas grid to hydrogen. So, well, I think a fairly broad set of topics that we've worked on. So happy to talk about that later if there are any questions on it. Because today what I want to do is give you really a helicopter view. So if you are in this expo, you've seen a lot of, let's say, very interesting ideas, very interesting engineering solutions. But I will try to give you a bit of a helicopter view, a bit of a business perspective on how we are seeing that hydrogen market developing. So I will cover demand, supply, transport, and I will finish with some of the observations around market dynamics. But let's start first with a very short introduction. You probably will know this, but just to give you let's say, introduction into the story that I want to tell you. Because of course we all know that we're facing a dual challenge with rising energy demand that we need to supply with renewables. In what way or form that is. And of course the challenge to lower our emissions, where we want to reach net zero emissions in 2070 or even earlier, especially in Europe. But of course our energy system is currently formed around 80% of fossil fuels, and only 20% is formed by green electrons or green molecules. And we need to change that system towards a more balanced view of electrons, which will be supplied with green electricity, and green molecules. And you will see that there are various sectors that will use those green molecules, but a lot of those sectors can't be fully electrified because they need molecules as feedstock, for example in the steel industry, in the fertilizer industry. Because there are technical limitations to batteries. I think the story of Spain and the mobility solutions there provide a good example of that. And of course, because we have high temperature needs in some of the industrial sectors. Then there are of course also sectors that are, let's say, where we need to see whether hydrogen will play a role. And that's because of the economic reasons more behind it. So that's in buildings, where I think there's a question mark what role hydrogen will take in the building sector, as well as some of the other industrial sectors. But what we should not forget is that hydrogen is part of the solution. Because if we talk to clients, we got the question quite often whether hydrogen is actually a hype or hope. And I truly believe that hydrogen will take a large role in our energy system, but we should not forget it is part of the solution. So we should, of course, start with energy efficiency and reducing our energy use. Then we go into renewable electrification, and only then we get into sustainable fuels, where, of course, hydrogen will play a role, and its derivatives like ammonia, methanol, and, of course, also biofuels. Why are these fuels so important? Because there are limits to electrification, as I just mentioned, because of combustibility to reach high temperatures, because of the energy density that you need in especially mobile applications, because of the flexibility you need to match supply and demand in the electricity sector, and because of the feedstock requirements in some of the industrial sectors. So why hydrogen then now? Because hydrogen has been talked about for decades. Already in the 60s, there has been talk about hydrogen, and even, I mean, if you go further back, you'll get to Jules Verne that has had his vision on the application of hydrogen on large scale. But I think what has changed is, well, we have commercial electricity, commercial renewable electricity that is superfluous at moments. And we need to match supply and demand in the electricity system, so therefore we need to have storage applications. But we also have seen signs of cost declines in electrolyzer manufacturers, that we can see that industry could move the same way as solar PV and wind has done over the last decade, which were, of course, surprises for many in the industry. We could see that similarly in the electrolysis industry, but that still needs to be proven, right? Of course, and there are also, especially in this part of Europe, we have grid congestion issues, so where we need to have different molecules to transport energy, basically, just because the grid is not capable to maintain the higher levels of electricity demand that we are seeing. Of course, next to that, it's also very much governmental pushed. On the back of COVID recovery schemes, we see a lot of funds becoming available in Europe, as well as in the Netherlands and in different parts of Europe, where we see different hydrogen strategies being deployed by different countries. So we see, and the first point, very important, we see a change of, let's say, focus on getting the electricity system more renewable to the focus on the hard-to-abate sectors, where hydrogen will definitely play a large role. If you want to spend your days during the week on just getting an overview of all the things that are happening, you can easily spend more than your day, because there are a lot of things happening, of course. So on the left-hand side, just a couple of announcements that has been put out in the market in the last month. We've been working with NordH2 and OCI. OCI is a fertilizer company that you might know, where we have announced the collaboration between NordH2 and OCI. But of course, a lot of hydrogen projects are being announced throughout Europe, in the US, and as well as in Asia. Let me skip this and let's go into demand. Let's get directly into this picture, where we see hydrogen will play the biggest role in the next coming decades. Of course, refining will play a big role for this industry, as well as the fertilizer industry, the steel industry, as well as, let's say, mobile applications, such as road freight. I think the Spain example, again, gives a good example of that. That will be the most important sectors for, let's say, the 2030s time frame. Only after that, we'll see other sectors play a role as well. And those sectors that are, let's say, most relevant currently will always be pipeline connected, just because that will be the sector that will be the way of transporting which is most economically. Then, of course, there's a road freight sector, which is a bit different, where you could see a decentralized electrolysis or even transport of hydrogen via trucking. But for the big industrial application of hydrogen, it will be refining, fertilizers, and the steel industry, where we already see concrete plants being developed as well. Because if you look at, let's say, the basic economics of these different industries, this is a total cost of ownership analysis of the different sectors, where we compared the most relevant, or let's most promising decarbonization options that these industries have. I will not go into detail too much here, but if you just look at the steel industry basically has two ways of decarbonizing. One is a direct reduced iron with an electric arc furnace using natural gas, or using that same technology but then with hydrogen. And you see, for example, in the fertilizer industry, they already use a lot of hydrogen that can easily be translated to green ammonia. Oh, sorry. So this is ammonia. And you see that prices in 2030 for application of hydrogen will be more expensive than maybe some of the alternatives. However, you must remember that this is let's say, war assumptions. And currently already, green hydrogen is competitive with grey hydrogen in the Netherlands. The problem, of course, is, and this I think is a public secret, is that the fertilizer industry, for example, is not producing anymore currently in the Netherlands just because of the high natural gas prices. So the real alternative for that industry actually is importing, not so much domestic production of fertilizers in the Netherlands. All right, let's go into supply. Probably I don't have to explain you the differences between grey, blue, and green. But I think what is important if you look at green hydrogen is that we should not forget that the most capex investment producing green hydrogen is actually in the offshore wind part. So 70% of the capex cost of offshore wind and electrolysis is actually in the offshore wind part, not so much in the electrolysis part. Of course, large capex investment still involved here, but I think a good thing to remember. And this part, so we are today here in Rotterdam, and actually, if you look at the promise of hydrogen and where it will take a role going forward, is actually that this part of Europe is very well suited to play an important role in that hydrogen development. Because of the relatively shallow North Sea, we see offshore wind being there, a promising renewable energy source. We have a gas grid that we can relatively easily repurpose, and we have storage locations in form of salt caverns where we can store that hydrogen. So actually this is an ideal situation to really form that hydrogen market. Next to that, of course, we have large demand centers. So we have a concentration of steel plants, fertilizer industry, petrochemical sites. So an ideal situation to get that hydrogen market rolling. Yeah, I already mentioned a bit about prices, right? So if you look at the price scenarios which were pre-war, and you see the solid lines, blue and gray, those are basically underneath the current range of green hydrogen production facilities. But with rising natural gas prices, you see that green hydrogen becomes more attractive. So domestic produced green hydrogen becomes competitive already in the coming years, which was very different from, let's say, a perspective that we had maybe a year ago. Having said that, of course, blue hydrogen will also play a role, but the problem of blue hydrogen, of course, is natural gas dependent, and the subsidies that are being applied relate to the CCS price that comes from the European market, which also has risen. So the current CCS plants actually will not get too much of subsidies just because of the situation with natural gas price as well as with the ETS. All in favor, I would say, for domestically produced green hydrogen. But one important thing to remember is that we're looking at a market which actually will be very tight. If you look at the demand of hydrogen that we are expecting, it will exceed supply quite dramatically. So we'll face, in the coming decade, a very tight supply of hydrogen in that market. And that, of course, then makes a case for importing of hydrogen. Importing of hydrogen will be most promising if it can be pipeline transport. So Northern Africa, the south of Europe, maybe a bit of the Nordics, but I think there needs to be, well, let's say some caution on how we think about importing of hydrogen via, let's say ships, which is really liquid hydrogen or in the form of ammonia, because we do see that there is a tight market and therefore a case for importing of hydrogen, but those conversion losses will be quite extreme. And you see on the right-hand side analysis of different importing regions where you also see the conversion and transport costs that are involved, which you should take into account when comparing and seeing how competitively you can produce hydrogen domestically. And what we're currently seeing is domestic production of hydrogen in the Netherlands can be very competitive against import. Let's not get into much of here. Looking at the time, I think what you will see is across the globe you will have different roles that various geographies will play in that hydrogen market. So we've been working with, for example, Japanese companies that are really looking into how can we supply technologies that will be applied in that hydrogen market, hydrogen burners or fuel cells or all that kind of stuff. At the same time, of course, it's a region which has very little domestic energy sources, so we'll import hydrogen from, for example, Australia or other regions. Then, of course, Australia, a large energy exporter, and will continue to do so on the back of hydrogen as well. Same holds for Saudi Arabia, and I think the broader Middle East, of course, very well suited in the oil and gas era, but will also play a big role in hydrogen just because of the cheap renewable energy source that they have and the applicability of transport that they can potentially do. But I think what the big question mark will be is whether industry that is currently, let's say, based in Europe will move to, let's say, those regions with very cheap renewable electricity sources. So will the steel industry remain in Europe? Will the fertilizer industry remain in Europe if it can produce, if it can become closer, let's say, to very cheap renewable electricity sources, for example, in the Middle East? Then, of course, Europe, which will be a very much importing region, will be the drive for that hydrogen market. So will play a very big role in the development of that hydrogen market as well. All right, so let's get into transport. And I think I have 5 to 10 minutes left. Yeah, something like that. All right, oops. Yeah, so let's skip this one. And let's get here. So if you look at transport, as I mentioned, large-scale transport on long distances and high volumes will be pipeline dominated. However, of course, there are reasons to believe that you can transport hydrogen in different ways or forms on, let's say, smaller scale or smaller distances. And trucking will have a role, but only on smaller distances and smaller volumes. Then, of course, there's potentially a role for ships as well, especially on the very long distance and the very large volumes. But it will, so for let's say, the coming decade, it will be pipeline dominated, just because we can use the existing natural gas grid and repurpose that to transport hydrogen, and there are very concrete plans to start doing that, being the European backbone plans, where you'll see that European backbone will actually start in the Netherlands. Gasunie has very concrete plans to have that backbone repurposed, based on repurposed natural gas pipelines in 2027, and that will kickstart the further transportation of hydrogen throughout Europe. All right, last part is on market dynamics, because of what I already said is the tight market, but actually what we're seeing is that many players are waiting on each other because there's a lot of uncertainty in the market. Uncertainty around, let's say, if there's enough production infrastructure available, which technologies will then be dominant, what regulations will be put in place, what fueling infrastructure there will be available, and you see that this is a virtuous cycle, where you already see that Europe is, let's say, the European Commission is already playing a role in trying to break this vicious cycle and make sure that there is enough certainty for the market to be developed. However, if you look at the Netherlands, we still see that there is very much requirement to enable the emergence of supply and demand collectively, because we're currently not seeing that yet, and that requires that current subsidy mechanisms should be, let's say, adjusted to make sure that not only that supply can emerge as simultaneous with demand. Because if you look at large-scale hydrogen developers as well as the demand side, they can't take FIDs without securing either production or demand. So they need to emerge collectively. Shows then that consortia are forming. And you see a lot of this in the market. Nord H2, of course, being one of them, where you see that companies are trying to mitigate risk by forming consortia, which are dominated, well, in Europe, but also in more and more in Asia, Australia, and North America. If you look at venture capital and where venture capital is now going into, you see that that is really on an exponential curve. So if you look at Q1 of this year, you already see, and translate that to the rest of this year, you see that venture capital investments in this hydrogen market are really on an exponential curve. And we're expecting a next record on venture capital investments in this hydrogen market this year, around 4 billion. So I think this is good news, but yeah, of course, a lot of risk still involved here. Let me skip this one and just go into some final observations. I think I mentioned hydrogen demand and supply are growing really rapidly, where we look at especially the fertilizer, chemical, road, freight, and steel sector. But that market will be dominated by an undersupply of hydrogen in the coming decades. So you will have a tight market for the years to come, where the requirement to secure hydrogen secure that green hydrogen production will be vital for the decarbonization of the heavy industry. Transport will be dominated by let's say, pipeline transport, and I think there is a very good case to make for the hydrogen derivatives like ammonia, methanol, but I think that it's still uncertain whether you will see a market developing from that will form hydrogen going into ammonia and then back into hydrogen. I think that those conversion losses will be very difficult to accommodate. But what you will see is that hydrogen production that will be used for ammonia will, well, potentially move outside of Europe and go to the Middle East, for example, if not sufficiently, let's say, legislation will be put in place to maintain that industry in Europe. So I think those are, well, let's say, my perspective in a very brief overview. But I'm keen to get your thoughts, and if there are any questions, please let me know. Thank you.